So this is my second shot at this. The Azure dashboard was in the dark mode, and the other parts of this presentation were in light mode, and it just totally messed up the white balance of the color. But you don't care because you never saw the other one. So here's what we're going to talk about. What can we do to monitor our broadband connection and understand whether we're getting the service that we're paying for? And is it possible to compare the internet connections at different sites with a simple dashboard that doesn't cost anything or very much? That's what I'm going to do. So I created a GitHub repo full of code, and basically you can run it on your laptop or a Raspberry Pi, and it will, if you want, push data to the Azure dashboard where you can see it from anywhere on the planet. That's the cool part. And actually, at the level we're using this, I don't think the dashboard's going to cost anything. Right now, my prediction on my Azure dashboard is this is going to cost me a penny a month. So we'll see how that works out. So what do? We're actually going to run a broadband test and record the results. And I'm going to show you real quick. We're going to run the speed test .NET API, which does a setup, gets the nearest servers, runs a ping, optionally runs an upload and a download because those eat bandwidth, and it records the metrics to Azure Application Insight, which is an APM tool that we can use for anything we want. We just send it metrics. So in this case, I'm just going to give you an idea of what this pointed out. I have two data providers. One is Verizon Fios in an urban area, and the other is Mediacom in a rural area. So one is Fios and one is a cable company. And so they're asymmetrical to begin with, and it turns out they run their operations completely differently. So in this case, this is the ping time as reported by the CLI, the command line interface kind of tool, this Python library that talks to the speedtest.net. And so you can see here that as I move across, you can see the yellow, which is the Verizon, and you can see that it generally setting up the initial ping to speed test is about 7 milliseconds, and on Mediacom it's about 50 milliseconds, right? So it's a pretty big difference. And then twice we got these huge outliers. So I don't know what happened. I don't know if the internet glitched or the cable modem or something else. So this is actually the reason that we're looking at this. That's because we want to see if Mediacom is consistent and in general what these two providers look like. And if you only have one provider, then you'll only have one chart. The other one I wanted to talk a little bit about here, a second one, is download speed. So in this case, both of these are gigabit download. I have a Raspberry Pi 4 sitting at each. Could have been a laptop, but the Raspberry Pi 4, I'm not too worried if something happens to it. These are gigabit download speeds. You can see that Fios here gives us about 700 to 800 megabit down for this test. I actually know you can get higher because I've done it when downloading Xbox games. And the speed test, the best I was getting 600 for a while, but right now in the last day, 12 hours, we've only got about 200 megabyte down. So I don't know if that's who they're hooked to or my pipe. I don't know. The pipe, anyway. So that's pretty interesting. This is actually what we wanted to see, paying for gigabit, but getting different classes of service. Now on cable modems, it's a little different. On Fios, you get symmetrical up and down. Before we were getting like 800 down, we're getting about 500-600 up, but that could easily be because the target servers are limited, so it's not really a surprise that we're getting 500-600 meg up. That's pretty good. On the Mediacom cable modem side, cable modems always are dramatically less. In this case, we get about 56. Let's look. We get about 52, 56, and 52. So about 52 meg up. I'm paying for, or whoever's paying for 50 meg up. So they're actually getting that. But you can see the big difference here in the cable modem, and the variability is not too bad on those two. So the other thing that I thought was interesting, the way this chart works, the way this program works, right, is it goes and does a setup, gets the nearest server to figure out what's the best one to test with, and so that calculation could be wrong, and that can affect your ping time and your upload download time. But it also could be wrong because there's like other weird stuff going on. So that was this other chart. This chart is how long does it take to find out, how long does it take to figure out what the closest server is so that it can run the test. And I find it really interesting. Verizon figures it out in about 1.5 seconds. 1.5 seconds, pretty regularly. You can see across the bottom, they know what server they're going to test with. On the cable modem side, and this is Mediacom again, on the cable modem side, it can take anywhere from 5 seconds to 40 seconds, 45 seconds. And that is crazy. So I don't know if they just don't put any Speedtest.net server support in their own data centers, like on their backbone, or what the deal is, but you can sit there and run this test and it just sits. And that's because sometimes it'll take, 15, 20 seconds just to figure out what server it's going to go to. And that is not good. It makes me wonder if there's a DNS issue or some other issues. And so I'd like to add DNS to this. So that's pretty much it. The only other thing here is this is basically the flow. This program's pretty simple. There's two parts. One is the net check part, and the other is posting it to the dashboard. And I love the dashboard because you can see the dashboard from anywhere. So you can post to the same dashboard from anywhere, and you can see it from anywhere. You don't have to VPN in or do anything else to see it. The cloud is amazing. So in this case, we run a couple stages to talk to SpeedCheck, and then we export the results up to the Raspberry Pi. I threw an extra thing in for people that want to send data to Azure App Insights or to an APM dashboard. I also hooked up a log message to this. So not only can we send metrics, we can send logs. And that's pretty much what you want to do is go to this repo. It has the same chart we just looked at. And it will also has another picture, but in dark mode. And then these are the scripts you use. Basically, you git clone this thing down to whatever machine, PC or Raspberry Pi or a Mac or a Linux machine you want to do this on, and you run the setup. And then if you want this to run it on a regular basis, then you can install it in a cron tab. On Windows, we didn't do that. I didn't do I didn't do that. The only setup program I did for Windows was to actually install all the components, and then you can run it by hand. I didn't do any scheduled job for that. And then the three Python files are the ones that actually do the work. And then I also describe how you run it by hand, which is cool, of course, and what kind of results would look like, and then how to hook it up with Azure App Insights, and then to tell you how to build a dashboard for this. And I have three blog article things, and will be videos that'll probably show you about how to do this too. And I also talk about how dimensions work in Azure App Insights for this, and that will probably be a different talk. This one is really about if I want to run a dashboard and get an idea what my broadband connection looks like, how can I do that? I'll do a different one on how to build a dashboard. But that's it. I hope that works for you because it worked for me, and but that didn't sound weird at all. Have a great day anyway.